Well, this is a solid model of the machine that we're talking about, and this is the table, and this is where you mount your product. This is an 8-inch by 8-inch surface, and this is the elastic bands that we have. These are 1-inch diameter bungees. We have them on all corners of this machine, and we raise this table with these lifting structures. We've removed some of the elements to have clarity, but this is a electric hoist lift system. We raise it to the top of the machine from here all the way up in here. It's on this model, it's roughly 100 inches. And we raise it, we hold it, and then we charge a pneumatic cylinder, a high pressure pneumatic cylinder down here, and hold this base, this blue seismic reaction base. And in this model, this base is roughly 10 times the mass of the table. We control the impact by having the same guide rod system, bearing system, so that there's nothing ambiguous about where this thing hits. It's the same each and every time. So
you charge up the cylinder with some pressure. You pull the table all the way up to the top, and then you kind of release those two things more or less in the same time frame.
Yes.
The seismic base shoots up the guide rods as the table hurtles down the guide rods.
Yes. And we release this. We actually release the seismic. We have the ability to release the seismic first or the table first. It all depends on the performance that you're expecting, the product that you're putting on the table, but you have the ability to manipulate one versus the other.
So you can control the timing about when those two things actually meet and come together.
Now, this is the drawing up the table. As we said, it's got an electric hoist lift system. The bungees are getting more force is being applied as we elongate the bungees.
So they're like big rubber bands, and the farther you stretch them, the more they want to pull back.
Yeah.
So up at the top is the table, where you mount the specimen, that's what's going up. And down at the bottom, the blue thing there, that's the seismic that's going to pop up and meet the...
It's going to be propelled, yeah. That would be the highest position.
So obviously you've got accelerometers on this thing to measure what it's doing and how much velocity is happening here.
Yeah. I don't know the exact settings on this test that we just did, but the event is so quick that high-speed videos are essential for...
You can't really see this happen in real time.
No, you can't. You can.
As soon as you say drop, it's...
It's over, yeah. So high speed is very important if you'd like to see the behavior of your test specimen during the event. Otherwise, you're just going to hear it. Yeah, it's so quick.
So what kind of velocity changes can you get to with this thing? What kind of energy are we talking about?
We were able to achieve on this 8-inch by 8-inch platform about 100 a bare table, unloaded. We were able to achieve about 160 feet per second, which is in the area of about a velocity change of 110 miles an hour in about 9 feet, 10 feet.
Jeez. Wow.
As we loaded it with a 15-pound product, we were able to achieve a velocity change in the area of 150 feet per second and acceleration levels of 26,000 Gs for 0.3 milliseconds. The peak force during this event that we were just talking about on this 8-inch by 8-inch table is roughly 2.5 million pounds force. So at the peak point of this event, the amount of acceleration and or force is quite substantial.
So this is looking from the bottom up.
The table re-engagement, securing the table after the impact.
And this is looking from the top of the machine down.
And that was an impact in real time. Yeah.
How long did this machine take to design, from the time the customer asked for it until the time it's ready to go out the door? How long a period of time did this take?
Roughly 8 months from the original concept, design process, the manufacturing, the hardware, the reassembly, and the performance evaluation, the checkout, and the completion of the machine before we shipped it was roughly 8 months. It's only a few more months longer than a currently designed product. These are very important machines. This is a military application, and we want to put it in the hands of the
people that can put it to good use.
Use as soon as possible.
Yeah.
So, yeah.
High priority.
It's a very high priority machine. Very high priority.